Welcome to Pomodoro Joe for Thursday, July 13th, 2023. Today we're doing LeetCode problem 207, course schedule. This is a medium problem. There are a total of num courses you have to take, labeled from 0 to num courses -1. You are given an array, prerequisites, where prerequisites index I is equal to A sub I, B sub I, indicates that you must take the course B sub I first if you want to take course A sub I. For example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. Return true if you can finish all courses, otherwise return false. Alright, so this is basically the same problem we just did yesterday, so this should be pretty straightforward. So the question is, how would you not be able to take all the courses? Like if you just have these prerequisites, you just take those prerequisites first. So how would you not be able to do this? Well, the answer is if you have a cycle. So we can look at the examples here. So num courses 2, prerequisite 0, 1. So in order to take course 1, you have to take course 0 first. And it looks like we can do it because you just do course 0, then you do course 1. All right. So example 2, you have prerequisites 1, 0 and 0, 1. So this one says in order to take course 1, you have to take course 0 first. But in order to take course 0, you have to take course 1 first. So this has a cycle. So it's impossible. So we're basically just looking for cycles in our data. All right. So this is exactly like yesterday's problem, which was LeetCode 802. So we'll just knock this one out really quick. All right, and I think we are done. Let's give it a shot. And it works. All right, well, thanks so much for watching. This has been fun. I'm just kidding. All right, so we know we can do this one. It's not that long. It's about 30 lines of code. So yeah, let's just do this one from the start. Let's put 25 minutes on the Pomodoro timer and we will get started. So let's start with the basics. We know we need to go through every course in our courses, in our num courses, and see if we can actually take that course. If we can't take any one of those courses, then we return false. If we're allowed to take all those courses, we can return true. So let's just have this for loop. So for course in range num courses. So this will just give us back all of the different course numbers, so 0 through num courses -1. Then we can say if we can't, so, well, let's do this here. If can take course, we'll pass in the course, then we'll continue. But I think I want to say if we can't take the course, then we'll just exit and return false. So if not can take course, we'll return false. Otherwise, if we go through, we check all of our courses and we can take them, then we'll return true. All right, so that's pretty straightforward so far. Now this can take course. This we don't have. We'll have to create this function. So we have our can take course function, and we'll pass in the course. Okay, so how do we know if we can take this course? Well, we can take this course if we can take all of this course's prerequisites. So for that, we'll have a recursive function. So let's just get all the prerequisites. Prereqs. Let's see. For this, we have to go through and find all the prerequisites for this course. Now, we don't actually have the prerequisites for this course because we're given this list of prerequisites. But the way it's given to us, we don't have a simple way of just saying, for this course, give me the prerequisites. We have to go through all of these prerequisites first to create our mapping. So let's have a prerequisite map here. And this will be a default dictionary of lists. And I'll put a little note here. So the key will be the course, and the value, well, that's just going to be a list of all the prerequisites for that course. All right, so we've declared our prerequisite map. Now we have to go through all of our prerequisites So this just means a course that you have to take before you're allowed to take the other course. So for every prerequisite in our prerequisites, so this has an A and a B. So I'm just gonna, instead of using this, I'll just give it an A and a B. So you're allowed to do this in Python. So we're going through every prerequisite and we're actually extracting both the A and B from that prerequisite. Next, we'll add this to our prerequisite map. So let's see, our prerequisite map. In this it says we have A and B. This indicates that you must take course B first if you want to take course A. So in this case, our prerequisite map for A will just append B. So we have to take B before we're allowed to do A. So now that we have our mapping, we can use this down here. So our prerequisites for this course will just be our prerequisite map for this course, because this maps our course to all of its prerequisite courses. Okay, then we just have to go through and make sure we can do all the prerequisites. So for every prerequisite in our prereqs, can we do it? So this is our recursive call. So if we can't take this course, pass in the prereq, so we'll return false. Okay, again, we're just going to go through all the prerequisites for this course. For every prerequisite in this list, we'll just check, can we take this prerequisite? Can we take this course? And if we can't, then we return false. If we make it to the end, if we go through all of our prerequisite courses and we can take them, then we can return true. So this is a recursive function because this function calls itself. Now in every recursive function, you have to have a base case. That is a case that doesn't get into the recursive call. So it has to exit before we get to this point here. All right. So one of the ways we could do that is we can check if this course doesn't have any prerequisites, then we can exit out. But we don't need to worry about that because if we're going through all the prerequisites in this list and there aren't any, we won't go through this loop. We'll just skip to this end and we'll return true. So this kind of handles one of our base cases for us. Now the other base case is the loop case or the cycle case. So this would be a case where we actually run into a prerequisite that requires a course that is basically required by the same prerequisite. So typically this would be done in a graph type traversal, where we keep a visited list or a prerequisite seen list. We'll call it visited. We'll just make it a set. So in this case, if we've already seen this course, that means we've had to take this course previously to taking this course, there's a cycle. So if the course is in visited, then we return false. Otherwise, we'll add this course to visited, and we can move on. All right, so again, this is just detecting if there's a cycle. So if we haven't seen this course, we'll get past this point, we'll add the course to our visited list. If we then do our recursive function call and it ends up requiring this course again, it will be in the visited list, the course will be in visited and will return false. So this should work pretty well, but we will have to reset our visited every time we go through the loop. So we have to set this to none to start with. We don't have to, but I prefer to. Then for every course, we have to reset our visited to a new set. This way, every time we check a course, it will check all the prerequisites for just that course, and we don't have to worry about running into a visited that we ran into previously for a course that we've already checked. If that makes sense. All right, so this should work. Let's try it. And this works. Now, I'll go ahead and submit this, but there's some optimizations we can make, and I'll go back and do those after we submit this, if this passes. Oh, we get the wrong answer. We said false when it was expected true. So we'll use this test case. All right, we'll jump back here. Okay, so here's the problem that we're running into with this one. We have 3 depending on 1. 3 also depends on 2. So we'll check 1, but 1 depends on 4. So 4 puts into our visited list. Then we come back. 3 also depends on 2. 2 depends on 4. When we go through, that's also in the visited list because 4 was put into the visited list for 1 and we return false. But since 4 was okay, 4 was required for both 2 and 1, we could actually complete both of those courses. So this is where our solution breaks down. So rather than just use visited, we'll use dynamic programming for this. So instead of having a visited, we'll have a is course takeable. So we create some dynamic programming array that starts as none for all the courses. None just means we don't know if this course is takeable or not. Then instead of checking if course is in visited, we can check here. If DP for this course is not none, then we can return DP for this course. That means we know it's either takeable or not takeable. All right, and then instead of setting visited here, at this point we have to decide if it's takeable or not. So we're just going to assume that it's not. So this just means we've visited this course. But if we make it past all of its prerequisites, then we will reset this DP to true here. All right, I think this handles it. Let's do that. Okay, so the changes that we made here, we took away our visited, which simply said whether or not we had seen that course before. We've replaced that with some dynamic programming, which is an array that tells us whether or not we can actually take this course. If we don't know whether or not we can take the course, we'll assume that we can't by setting it to false. Then we'll check all of its prerequisites. If we make it past all the prerequisites, then we can set this DP to true for this course. Now, one thing I didn't do, I need to set it here as well. I don't know if this is strictly necessary because we're already setting it here, so probably not necessary. Actually, let's not do it. Let's just see. I don't think it's necessary. All right. So let's see if this works. Cool. So this does pass the one test case we weren't passing before. Let's submit that. All right, and we pass, and we do all right. We beat 78% for runtime and 62% for memory. That's not too bad. We did go through this one wrong answer. I'm a little bit bummed by that. That's because I was trying to do something new and it didn't work out. All right, so what can we do in this? I don't know if there's a lot I can do. I guess I don't need this visited. That might help speed things up just a little bit. Let's see. We might not need this. That might speed things up. All right, let's just try this, see if we can speed up just a little bit. That actually slowed things down? That doesn't make any sense at all. Yeah, that doesn't make any sense. All right, let's jump back here. Let's just get rid of this one variable. We can just replace it directly with that. All right, I think we still need everything else. Try this. Wow, now we're at 50%. That's so weird. One thing we could do, flip this around. If DP course is equal to none, then we'll do all of this. And at the very end, we will return DP at course. Whoa, and that's a huge gain. Now we're at 93.39% for runtime and 62% for memory. So the main difference here is we just did this if differently. So instead of saying if this isn't none, return DP of course, we're saying if this is none, then we'll run through this. It's a little bit shorter code, so maybe that's the difference. Yeah, that's crazy. All right, well that is it for me. So for this one, we had to create our own mapping by using our prerequisite list of edges to create a map for every course and all of its prerequisites. Then we had to go through every course, check to see if that course is takeable, if we can take that course. If we can't, we'll return false. If we can, we return true. And for that, we actually had to create this can take course. This has dynamic programming or memoization to keep track of whether or not we can take this course. So if we don't know whether or not we can take the course, we assume we can't unless we go through all of its prerequisites and find out that we can. Then we'll reset this to true. Otherwise, we just return the memoized can take course answer. All right. And for this, we got a 93% for runtime and a 62% for memory, so not too bad. All right, hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.